Hello and welcome to this Ubisense webinar, Yard Management, How to Locate and Manage Work in Progress Across Your Facilities. I'm your host, Stephen Manifold, Chief Marketing Officer at Ubisense, and I'm delighted you've chosen to spend some time with us this morning to learn about this topic and see some of the examples in action. For those that are new to Ubisense, we're a global company headquartered out of Cambridge, England, and we track the precise location, movement, and interaction of things using our Dimension 4 sensor system and our smart space software platform. And we do this to help organizations improve productivity, quality, and safety. Before I introduce our speaker today, who will share how this applies in particular to yard management, I'd like to quickly run through a few short housekeeping items. Firstly, the webinar today is being recorded, and a link to the recording will be sent within 24 hours from the end of today's session. The recorded version will be available on demand for 12 months on ubisense.com, should you wish to revisit it in the future, or indeed share it with colleagues, partners, or customers. The presentation material covered today will be made available on request, and details of how to request that will be provided at the end of the webinar today. And finally, we've allowed some time at the end of the webinar for some questions and answers. If you have a question, please feel free to raise it in the chat or question window during the webinar itself, and we'll respond to all questions at the end of the session. So with that, and without further ado, I'd really like to hand over to my colleague and our speaker today to introduce himself and take you through today's webinar. So Hubert, over to you, please.
Thanks, Stephen. So hi, everybody. I'm Hubert Peyre. I'm with Ubisense for almost 9 years now. I'm a business developer in Europe, and I'm going to present you this webinar about yard management. So I hope you will like it. All right, so let's get started. A quick run through the agenda. So I'm going to do a quick introduction, a very quick one. Then we're going to talk about the spatial intelligence concept. I'm going to run you through the yard management use case, what we mean by yard management in general. And I will present you the Ubisense yard management solution. This will include a demo, so please stay connected. And I'm going to go through some return on investment figures and a few references before we go to the Q&A session. All right, so let's start with a short introduction. So before we dive into the specific webinar, let's have a look at the big picture. So it's all about Industry 4.0 or digital factory. So if you search on the internet about Industry 4.0 or digital factory, you will find a lot of different definitions. But the one thing that pops out the most is about cyber physical systems. So what are cyber physical systems? You will also find a lot of definitions for that. But there is one that we like quite well, it's about computers with sufficient understanding of and interactivity with the physical world that they can help us plan, measure, manage, optimize, control, and error-proof complex processes. And I'm gonna come back onto what we mean by sufficient understanding. We're gonna talk about manual processes here, and I'm gonna talk about IoT a little bit here. And IoT will not digitize your full manual processes. So what is IoT? There is also many definitions on the internet, and there is this one from Trend Micro, which is the IoT can be described as an extension of the internet and other network connections to different sensors and devices, we call the things, affording even simple objects a higher degree of computing and analytical capabilities. So more or less, it's connecting simple devices or sensor to a higher degree of process power somewhere in the cloud. And that won't do everything for manual processes. This is an IoT view of the world. So you can see IoT sensor or devices at the bottom that send data stream to the cloud. where it is aggregated and analyzed. And here the focus is on the things. So the things, the tools, the machines, where there are those sensors fitted. So if you take an example of a factory which is fully automated, you have the process of the things. They execute the tasks all in a deterministic sequence. So that means if you monitor the things, it's equivalent to monitoring the process. So here IoT can help, and IoT can give you the state of your process. So let's describe it like that. With automated processes, the status of your process is defined by the aggregated state of the machines that complete the tasks. IoT creates a complete picture of the processes by monitoring and controlling the machine state. But often in the industry and in manufacturing, you have a lot of manual processes. You don't have only automated processes, unfortunately. And what the definition here of manual processes is that the status of your process is defined by the complex series of physical movement and complex interaction between people, tools, parts, and products. And here, IoT doesn't see all this activity, those interaction between things and people. And it must be augmented with something else to be able to deal with manual processes. If you see here, you have some parts of the manual process might have already some connectivity, some IoT connectivity, but that won't give you the full story of the process. You might have, for instance, the battery level of a forklift, but that will not tell you the whole story. What you need here is the process itself is defined by the interaction between the things, but not only the status of things. So I was talking about the battery level of the forklift. When we talk about the interaction of things, it's interaction between, for instance, here, parts and the forklift. So when the parts were picked, where they dropped, in which sequence they were dropped, is the tool working on the right product, is the operator in the right station, and so on. So that's the status of interaction with things. And this is those interactions, so the orange lines that we need to monitor, to digitize and to control so that we can error proof and along with the existing IoT thing data. Now let's discuss a little bit about the concept of spatial intelligence. So this is how we want to extend or how we augment IoT into manual processes. So we do have, what you see at the bottom is the physical world. So usually the first step to digitize is to put a layer, a sensing layer, where we will track location of things. We will also aggregate existing IoT data. And this will give us a full picture, a complete digital twin of your real world processes. Then what we have is another layer on top, which will transform coordinate of assets, X, Y, Z coordinates, which you don't really care about, but what you care about is more about an asset is entering into a zone, for instance, events. A product arrive at a station, for instance, and this layer is filtering those coordinates and generating important events. And then those events will be passed on an upper layer that will monitor those events to detect deviation. For instance, if you are tracking processes, deviation to the plan, and those deviations can be then delivered to existing IT systems, ERP, MES, or other higher systems that will then send that information to people, because there are always people behind systems that take those decisions. So if we summarize with the orange line you see before, the three layers of our smart space platform, so the software spatial intelligence platform, Those three layers are the ones that correspond to the interaction of things. They will be the layers monitoring the interaction of things in the real world. And that's the thing that IoT doesn't do. All right, so let's have a look at what we call the yard management use case here. So about the challenges, what are the challenges of yard management? So usually manufacturer medium to high volumes of finished and unfinished products that are widely dispersed around sites. So they can be indoor, but they can be also outdoor. They don't have a real-time view of their product locations. The sites are usually very big. And the way the process is handled is that you often have a manual declaration of location. And often it's paper-based. Sometimes it's on tablet, but often it's paper-based. And those are still manual processes. So those products that move, they are moved by humans, by drivers, or by people that move them around. I picked one example here. That's a tractor plant. They are manufacturing tractors. That could be other products, but that's the example I took. So imagine a typical example is a driver, or sometimes it's called a jockey. They are asked to get a product and move it from place A to B. So in this case, the jockey is asked to take product 1, 2, 3, 4 from this parking, which is parking 1, row B, bay 15, and to take it to test bench 3, which is a different building. So the driver goes there. So this is where test bench 3 is, on the different building. So the driver goes there on the parking area where the product is supposed to be. He's going there, but the product is not there. So he's spending 10 minutes looking around. You can see all the tractors are the same color, so it's difficult to find the right one. After 10 minutes, if he is an IoT connected jockey or driver, he will send through his tablet or his device an information to the system saying he couldn't find a product, and he will go to find another one. If he's not connected, he will have to go back to a fixed workstation and enter that he didn't find a product. So what happened in the meantime? Here the test bench 3 was left running empty for some time. So that's a big loss of productivity. Now, what happens when those drivers or jockey don't find a lot of tractor at the end of the day? They will do something. They will send a super finder that will do a complete inventory of the yard. I'm sure you've seen people like that on different companies. So they wander around the yard. They have a notebook with a piece of paper usually, and this is the layout of the plant with all the different parking bays that are on this layout, and they need to fill manually each individual product which is in which parking bays, and they do a complete inventory of that, and that takes time and money. So those challenges, what can they lead to? So as you've seen, extra labor cost to find products. If you don't find them instantly, you need to send new people to look for them. You can have increased cost from inefficient use of production resources. We saw that you can have some production resources left idle waiting for a product missing. You can have delayed product completion and delayed delivery schedules. And if you lose your product for quite some time, you can decrease their value. Let me show you some example of products we usually track on the yard. So that's just an example list. There are a lot of other stuff we are tracking on the yard as well. So that could be tractors, it could be van or light commercial vehicles, they could be trucks, they could be agricultural machineries like harvesters, they could be forklifts, they could be cars, they could be trailers in logistic areas as well. And as I said, many more. I also wanted to show you some example of sites to give you some ideas. For instance, that's an harvester site in the US, So you see, it's quite difficult to find the right product when they are all the same color and you have a huge yard. You can have different stuff like trucks on yard as well, so they can be very different or similar. You can have very difficult sites where the product have the same color, but they are all different. They all have different options. So when people are moving product to one place to another, if they make mistakes and the system is not reflecting the reality when they want to get the product back to do something on it, then they spend a lot of time, and sometimes they spend days to find it. That's another example more in the logistic area, where you see a lot of trailers. They more or less have all the same colors. So when you have the people from the internal logistic, they want to get the trailer to put it close to the manufacturing plant and to unload the trailer, sometimes they spend a lot of time to find them. And that can delay the production as well. So that was for the yard management use case. I'm gonna talk now about the Ubisense solution for the yard management challenges. So I was planning to put a little video. Let me check that. But I think the video is not there. So what I will propose you is that I will send the link at the end. This is a video which is available on the internet, which is a good summary of what is our yard management solution, and you can have a look at it after. But anyway, I will present all the features during the demo afterwards. All right, so let's talk about the solution functionalities. So what do we provide in the Ubisense yard management solution? So the first thing is a digital map of your facility. So we will load a CAD file, or we will load a 3D file of your site. We can improve it, putting some process context on it. Then we will define the different assets you want to track. So here, for instance, a tractor with its size and colors and model and so on. So it will have some properties, a name, a model, I said color, some age, the current location, and any property you may have in your company related to that. Usually we get those property through some integration with existing IT system like ERP or MES to populate the data model. And then we will define and configure what we call the spatial model or the space definition. So those are 3D volumes that can be fixed, like a workstation or parking area, but they can also move if they are attached to a product or something that moves. So they are in 3D. They can be concentric, so you can have like Russian dolls, different size inside each other. We can go down to the parking bay level, or even smaller for other use cases. And this is the basis of what I explained a little bit earlier about the spatial intelligence and transforming coordinates into events. So whenever we locate a product into those zones, we can fire an event. Some other functionalities. So usually when you are looking for things, you need maps and searches functionalities. So we have maps that are available on any web browser devices, such as PDA or tablet, phones, or desktops. We also have some alerts and notifications that I will show you in the demo. They can be visual, but they can also be sent via email or log into database. And we will have some standard reports that can be customized for different, let's say, specificity for use cases. So for instance, the location history, the time spent, the dwell time into different working zone, and so on. some other functionalities. We can connect the smart space platform, so the software platform, to any location system data. So if we track things indoor or outdoor, or indoor and outdoor, we can use some ultra wideband. If we want high accuracy, we can use BLE. Also indoor, we can use GPS trackers outdoor. We usually use a combination of 2 or more technologies to track indoor and outdoor into a single hardware device. We manage the tag association and deassociation, because usually when you track product, you have a product life cycle. So the product is being built, and at some stage it's shipped to the end customer. So there is a loop with the tag association and deassociation. We also manage the user access and authentication to the end user application that I will show you in the demo. We can use Active Directory or local user database for that. And as I was saying, we can integrate with business systems, existing business systems. For instance, ERP or MES or other quality systems. We can use web services, REST API, or specific .NET API when we have to connect to specific systems. We can also integrate directly with RDBS mapping. And if we want to log data for historical reports, like location history or dwell time in zone and so on, we can log that into a standard database such as Oracle or SQL Server. I'm gonna talk a little bit about the architecture. So what you can see here on the bottom is the location system layer. So there are many options, as I was saying, depending your specific needs. So I presented 2 here. So one option where you track using GPS outdoor and BLE sniffing indoor, where you don't need a high precision. Another one where you use GPS outdoor and you want more precision indoor, where you will use ultra wideband indoor. And that's embedded into a same device. So a tag or a device is the thing we attach to the product to track it indoor and outdoor. Then there is a second layer, which is about the location engine. So to compute, calculate the X, Y, Z coordinate of that product, of that tag. That can be local or on cloud. That depends the customer requirement. And then the most important part is the Ubisense Smart Space platform. So the location intelligence platform. If you remember, that's the 3 layers in the diagram where we saw the digital twin of the processes. And this layer will connect at the bottom with the location system. We'll be able on the right to provide information to users, and we'll connect on the top to existing customer business systems, ERP, MES, quality system, and many more. All right, so let's go to a demo now. Let me move. Hope you still see my screen. So before I jump into the end user interface, I just want to show you something which is about the configuration interface, where you can see when I was talking about spatial intelligence, and you can see the different 3D zones, 3D space that we configure. So you can see they could be in 3D. So I was saying that you can have concentric zones. So for instance, here you see a big zone for this building, and then inside you will have different subzones that correspond to different workstation or process area. If we check, for instance, outdoor, we can have parking rows, and we can even go down to the parking bay. So if you see here, those yellow arrows, they are what we call parking bays, and they are helping to improve the GPS accuracy. So we are filtering GPS signals and data outdoor, and those special parking bays, they are able to attract any product that are close by, like a magnet, to improve the precision of the GPS. So I just wanted to show you that spatial zones, so those 3D zones that are at the heart of the smart space engine. So now let's go back to the end user interface. So usually you arrive into a page like that. You get authenticated with a name, so either directly with your PC, laptop, or tablet, or you can enter a username and a password. And this authentication will help you, will provide you here different menus, depending the access right you have. So if you have an admin, you will have a lot of menus. If you are just an operator that want to look for products, you will have maybe only one menu with only one search, to be really precise. So it adapts to the roles of each operator that use smart space. So let's start with the most obvious, which will be a map. Usually what you need to do first is, the main challenges was to find stuff on the yard. So usually the first thing you want to do is you want to look for a specific product. So you will start by entering its product ID. So for instance, let me try with this one. I will try, let me type in XK70. I click on search, wrong one, sorry. Oh. Yes. So for instance, here I type in XK7. So there is only one tractor which has part of this substring in its name, and it will zoom in onto the tractor. So if I click on it, I can have here some more properties. So age, for instance, it's the time in day since we have associated a tag to the tractor, so since the beginning of the process. And here you have an information about the current location. So if I zoom out a little bit, you will see the full plant, which it's quite a big plant, so it's a tractor plant. If you click here onto this pop-up window onto the tractor image, you can see it bigger. So we use HTTP links. So for instance, if you want to connect to an existing business system, you can add here as a property the link to that specific business system, and when you will click on it, it will open your specific business system to the right pages. Now you can also enter a list of products. So let me put 1, 2, 3 here. So you see there are more products, more tractor here that contain those 2 substrings. If I click on another one here, it will zoom in. You will see that there are some decoration that appears on top of the tractors. So this one, for instance, means that this tractor did not move for a long time. It's called, it is what we call the non-mover. So we can generate those alerts to tell people that some of the product haven't moved for quite a long time with a threshold which is settable. If I pick another one, for instance, here, yes, you will have a different model with a different picture, different age also, and a different location. Now, if I show you, for instance, all the sites with all the tractors, go back a little bit here. So here it is. So you see there are 937 tractors onto the site, so it's quite a big site. If I zoom in a little bit, you will see that you have a lot of tractors with a lot of different, oops, sorry, I zoom in a little bit fast. So if I pick this one, for instance, you see that there is also another decoration on top, which is a mechanical issue. So based on product properties, we can display different decoration that can help people managing production and priorities to find and pick the right products. So you see here different columns that are settable. Also, we can configure the type of data you want to see here. So the tractor ID, there is the model, the age I was talking about since the beginning of the process, and its current location. Let me show you another one, a different search. So here are the list of all the searches available now. We can configure new ones, remove some of them, and for a specific profile, we can select how many searches we want to see. For instance, if you want an operator to look for product and he's always looking for product by ID, you will only allow him to see this tractor by ID search. So let me go through the tractor by location. So here we have the list of these virtual 3D zones, those spaces. So if, for instance, I want to look for all the tractor in the rework area, it will display me the list of all the tractor there. So that's the rework area, and will display the tractor on the map. Yes, here it is. So here you can see the decoration I was talking about. So for instance, this one has 3 different ones. It has 3 different quality issues. Let me pick another one. So we were talking about age tractor. So we can also look for old tractor. So that means they are in the process for a long time. So here you see that's quite a number of days, 123 days since the beginning of the process. So that's an information that can be important also when you manage your process. You can have tractors by options. For example, the option property is something we retrieve from EMES or an ERP system that we connect through our set of APIs, and we retrieve those properties and we insert it into SmartSpace regularly when we associate the tag at the beginning of the process. So for instance, if I want to look for tractors with front-end loader here, I can click on it and I see I have 28 tractors there, and I can see where they are on the map. If I click on one, for instance, I have it here. The option can be displayed here as well, and I can click here and get to a specific system maybe that displays the different option instruction. Another search which is displayed here is tractor by quality defects. So that's also some properties that we retrieve from existing business system. So if I want to look for all the tractor having electrical issues, I can search them here. I will have the list of the tractors and I can pick the one I want. And I can even filter out with a smaller number of tractors, all tractors that contain 12, for instance. One thing which I will guide you through also is about tag battery status. As you locate stuff indoor with, for instance, ultra-wideband and outdoor with GPS, you have a battery to manage onto your device, and it's important to manage that battery properly. So we can find tags, for instance, that have failing batteries. So for people that manage the processes, they can replace a battery if it's happening for some reason during the process. Usually we check the battery before we associate the tag, but if for some reason something is failing because the product has been spent years onto the yard, they can go and replace the battery or the tag. So that was about a lot of things about the maps. One thing that I haven't talked yet is about notification. You may have seen here a little pop-up moving. So when things are happening, for instance, a vehicle is entering into a zone or spending too much time, for instance here, a vehicle has spent too much time into an area, we can get those notifications here to appear visually or send via email. but we can also have some alerts when, for instance, a product arrives at a specific zones. So let me show you a specific one, which I will trigger a notification. So I will move one tractor, which is, let me find it here. This one here, which is closed, it's almost finished, and it will be shipped to the shipping area here. So I will simulate the movement of the tractor so that we can have a notification. All right, so I'm gonna move the tractor, so you should see it moving a little bit here on the map. There you go, so it's moving backward, but still it's moving. And then it will arrive in the shipping area. So now if we go back here to the notification area, you see that this tractor, that's the one where we're monitoring now, has arrived into the shipping area. And that's important for this customer because it will trigger some events to their business system saying to the ERP, now this product has arrived to the shipping area and has reached the end of the process cycle. So that's what I wanted to show you regarding the map and the notification. I will quickly go through a couple of reports for a minute or two. So as we are, let's say, aggregating a lot of data, we can, for instance, review the location history of a specific product. So in this example, we have typed in a product number, so that's a tractor number, and we want to see the location history this week. We can change it to a different date or time frame. And what you see here on the map is what we call the spaghetti diagram, or the full path that the tractor went through. So if you click on some of the dots, you will see exactly the time when it moved and the duration of the movement. So here for the simulation, it was a quick movement, but you can really see where the product did go through, and that can help people managing continuous improvement to find new ways of moving stuff or improving the processes. You can move here some sliders to go back in time if you want to see less or more history. And then a last report, that what we call a zone history, is you select, for instance, a product. You can filter by name, you can filter by time, and so on. And for this product, you will see the entry time and the exit time for each zone you went through, and with the accumulated dwell time is spent into those zones. So that gives you a more logical or functional view of the location history of that product. So there are still a lot of things I can show you, but I think I'm running out of time. So if you need more information on demo, we can pick this later. We can do a specific demo regarding the challenges you may have. So let me go back to the presentation. All right. So if we want to link what we've seen in the demo with what I presented in the spatial intelligence set of slides. So you have the physical world at the bottom. We take this example where a product is moved to an outdoor parking area. It was the shipping area in this case. So this is passed onto the digital process layer. So there was a GPS-enabled tag that compute the location of the product, and it will pass that location to the spatial model. So with those 3D volumes, those 3D zones, then the coordinates of the product are detected into those spatial zones inside the specific parking area. So that was the shipping area. And then the spatial model passed that event to the process model on top. Then what happens? The process model will pull the expecting parking area from the existing ERP MES system. And then there will be a comparison. The process model will compare the expecting parking area with the detecting parking area. And if there is an error, so if it doesn't match, we can trigger a notification or an alert that is sent to the HMI, so the user interface, or via emails, so that someone, a supervisor, is informed that there is a process deviation. Now let's have a look at return on investment and a couple of things about reference. So there are different types of return on investment. So some are easy to show, some are more difficult to highlight. So the easiest one is the one that are based on time and labor cost reduction, so reducing search time. If you find stuff very quickly, then you reduce labor time. If you reduce manual inputs into your system because of paper-based processes, you also reduce labor cost. You have also savings based on capital cost reduction. So if you improve resources utilization because you need less space outdoor in the yard to manage your processes, that's a big reduction in capital cost. You can improve also throughput with the system, and that will lead to a reduction in inventory. So when I mean in a reduction in inventory, is reduction in the number of products you have in your parking. So if you have a tractor that costs 200,000 euros and you manage to reduce your total inventory of 10, 20 or 30 tractors, that's a lot of money. That is not blocked anymore. It can be also based on production throughput increase. So you can improve order to delivery time, can improve resources utilization. That can, let's say, give you some margins for production ramp up, if you have any. Can also reduce bottlenecks because you have a better real-time view of the working progress of your product. And it can also be based on data unification or digitalization. So for example, improving production planning or cycle times, delivery planning, because you have real times and objective data. And it can also sometimes improve your ERP real-time knowledge of the production status. To give you some idea about numbers here, typical savings when you are looking for stuff on a yard, we've seen that often it's about 2 full-time employees that you can save. Depends on your site size, of course, and your processes. You can reduce from 5 to 10% of inventory reduction, so that's also a lot. You can have a customer satisfaction increase because you are delivering more on time than before, 5 to 10% of that. And you can have a 5 to 10% of productivity increase. This can even go higher when you add other use cases, such as process monitoring or product routing onto this yard management use case. And those will lead you to a typical 1 to 1.5 years return on investment of the solution. All right, a few words about the reference. So we have a lot of customers worldwide that have deployed that solution. So some in Japan for light truck manufacturing, some with vans in the US, some with large trucks manufacturing in Mexico, some large trucks manufacturing also in Germany, or tractor plants in France. We have also some tractors and agricultural machineries manufacturing plants in the US, and we have also some other logistic plants where we track trailers. Here I just want to reconnect a little bit this yard management use case, which is one example of what a spatial intelligence platform such as misplaced can do. So if you remember those orange line, which are the interactions between object, things and people, and that's the one we are monitoring. So in this yard management example, so I presented you this specific use case, but as I said, there are many other ones that we deal with that may be part of other webinars. And I wanted to give you a couple of words about what could be those other use cases. So if you go to this specific link onto our website, you will see some example of other use cases we are solving with this smart space software platform. And usually they fall into those 5 categories of manual process error. So location error, for example, things are in the wrong place. So that's typically the yard management example. Interaction, when you have 2 or more things that are interacting and shouldn't be. It could be a count category. There are too few or too many things in a certain place. There can be a duration. That's also something in the yard management use case. A task has taken too long or not long enough. The tractor spent too much time into a process, or tractor spent too much time into a parking area. And it could be also a sequence category, a sequence error. Things are happening in the wrong order. So yes, so that's opening to a lot of different use cases. I let you think about what type of use cases you can have in your manufacturing plant that could be addressed with smart space. And I think we will be now down to the question part.
Yes, thank you, Hubert. That was great. Lots of very good information there. And we do have actually quite a few questions already coming in. So I'm going to try and pose these quickly to you, Hubert, so we can get through them all. So the first question actually it asks if the software, the smart space software, can also track closed indoor areas and also assets that are different shapes and sizes or weights.
Yes. So smart space, the software platform is agnostic of the technology. So unfortunately, when you want to deal with several use cases, there is not a single hardware solution that will manage all the use cases. But smart space can connect to those different hardware solutions. So if you want a really precise location system indoor in a closed environment, you can use, there are a few different technologies we can use. If you have, for instance, very small items to track, we can also use passive RFID to connect to smart space for specific use cases. If we are outdoor, we can use some GPS-based devices. So depending the type of use case, we can find an hardware solution that can be connected to the smart space platform to address those use cases. And the good thing is that you then get a single software platform to deal with all the different hardware solution you may need to cover your use cases. I hope I answered the question.
Great, thanks, Hubert. We have another follow-on question to that, which is, can we track or manage where we have stacked crates or stacked assets? So for example, in being able to track in 3 dimensions, the height as well as the 2D location.
Yes, so I would say indoor we are doing it often. So when you stack product on top of each other in racks or so on, we can locate, for instance, using ultra-wideband or even with BLE in some circumstances, you can get the 3D position. So you will know on which layer you are on top of the 2D information. So you can know exactly on which layer you are. So when I was showing you those 3D volumes, we can stack 3D volumes on top of each other. So we can spatial monitors those movements of products or parts onto different layers. And I think there was a second part of the question which I missed.
No, I think you've answered it. So I think the other part was, when it's inside on, as you say, on stacked racks or crates that are stacked on top of each other. So I think you've
yeah. Now I remember what I wanted to say is when you want to track things outdoor and you want to, let's say, locate the height. If you are close to the building and you are able to deploy, for instance, an ultra-wideband infrastructure, you will be able to locate in 3 dimensions. If you use GPS, for instance, the Z coordinate of the GPS might not be precise enough to be able to provide smart space with the right level of information to know the height on a rack, for instance.
Great, thanks, Hubert. Another question we have is, do the ultra-wideband sensors have an accelerometer or similar inside them so that they can activate on movement or if acceleration is over a certain limit?
Yes, so our tags and also other devices, so if the question is about the ultra-wideband one, yes, we do have a kind of accelerometer inside where we can detect the movement of an object. And we usually use this to set up a different update rate of your asset. So for instance, when the asset is not moving, we can get its position every an hour or once a day. And when the asset moves, maybe we can get a position when it's outdoor using GPS every 10 minutes. And when it's indoor using ultra-wideband only, we can get, I don't know, maybe 4 times a second movement, so that we really get high fidelity data that we can filter out.
Fantastic. Next question, Hubert. Is there a minimum value of the asset to be tracked to get a good return on investment?
Well, that's a very complex question to answer, because it will really depends of your use case. Because you may, let's say, have low value equipment where you want to attach a tag and you want to track them, but they might, let's say, provide you a lot of savings which are not linked to the value of the equipment. I have to say that often the value of the equipment is quite high, obviously. You need to have quite a lot of those equipment. If you have only 20 outdoor, that may be not, let's say, good enough to get a good ROI. But if you have sufficient number of items outdoor and if they are moving often, yes, you will get a good ROI.
Great, thanks, Hubert. There's a follow-on question to that, which is there a more affordable configuration to track those lower asset values? I know you mentioned passive RFID during the presentation. Perhaps expand on that.
Yes, so what we can also do is what we call a combination of different technology, or what we call indirect tracking. For instance, outdoor, one possibility could be you put a passive RFID sticker or tag onto a low value item, which has a high number, a few thousand, for instance. And then when you drop it somewhere, you have a PDA or smartphone equipped with a GPS, and which has a RFID passive reader, and you will scan the passive tags where you dropped it, and that will link automatically the GPS position of that asset. So by combining two technologies, you can, let's say, address the same use case, but using a lower cost device that you can add onto your low value product.
Great, thanks, Hubert. So you can have lower value or lower cost tags to track things, or RFID, but just have the high value location, precise location on the reader itself.
Yes, that's really what we call indirect tracking, and there are really different combinations. You can have passive RFID with GPS. You can have indoor, for instance, passive RFID or barcode with ultra wideband or with high accuracy BLE, and I'm sure there are many others to come.
Fantastic. Thanks, Hubert. Another question here about the life cycle of the tag, and I think they're asking about precisely the battery management. So I guess how long the batteries last and what happens when they run out of power.
Yeah. So what I was saying during the presentation is that we are managing the life cycle, so the tag association. So it's the time when at the beginning of the process, you attach the tag to your product. So there is an automatic or manual process to do the association. Either you scan the tag and you scan your product, then you match them. And usually there is a check to be done on the battery. So if the battery is close to be flat or failing, then we will forbid the association with this tag, and we'll say, no, please put this tag aside have it maintained. If for some reason you get a tag in the field, in the yard, which has a low battery or close to low battery, because I don't know, maybe the product stayed there for a year or more, then we have some automatic alerts, as I showed you, where you can go and check and change, exchange the tag, for instance, or change the battery. And typically a battery will last. So it really depends if you do indoor, outdoor, or indoor only. So for instance, a ultra wideband tag, industrial tag, will last up to 10 years indoor with 1 Earth location update. If you take the same time with a GPS add-on on it, and you go outdoor, and you, depending the number of position you get per day, it can go to down to 2 or 3 years of battery life with the GPS enable.
Okay, great. Thanks, Hubert. So I guess multiple year battery life, but would you are the batteries replaceable?
Yes, so
yeah.
We can definitely replace the battery, so the end customer can do it. Usually our customer have implemented that into their tag process. So yeah, usually they put them aside, and when they have 20 or 30 that need services, then they change those batteries and put them back into the process loop.
Great, thanks, Hubert. And then we have one final question here. I think you touched on this a little bit. The question is, you know, can I add other use cases later if I start with tracking, for example, indoor, outdoor, or one or the other, or if I want to start tracking more than just the location of assets, can I add use cases later?
Yes, that's definitely one of the strengths of Smart Space, is that you can deploy Smart Space and start with one use case, and the day after, if you want to introduce a new use case, you don't need to, let's say, start from scratch again. We can add other use cases on top of Smart Space. So part of Smart Space, we can configure other use cases that can be linked to the same hardware or different hardware, and that is helping a lot with managing, let's say, IT silos, managing a lot of different applications. Then you just have one to maintain. You just have one or integration to the MES or ERP system to maintain as well. So usually people in IT, they like that.
Okay, excellent, great. I think we're just coming up to the hour. We have no more questions, Hubert, at this time. So what I suggest is we close out the webinar. I'd just like to close by saying thank you to all the attendees, and certainly thank you for really good engagement and lots of questions. As you can see on the screen here, you can access more information via the website. Feel free to reach out to Hubert directly if you'd like to follow up. Indeed, if you'd like to get access to the presentation material, again, please email Hubert directly or contact us via the website. And finally, again, just I'd say thank you for joining us today. Wish you a good rest of the day, and thank you very much, Hubert.
Thank you, Stephen. Thanks all. Bye-bye.
Bye for now.